is about integration techniques, and we don't need to know that except for the partial fractions. And I would not use the reading they have in the book because they make it harder than it is. Remember when we had, we didn't have this, we used the integral test, we could do that. Remember the collapsing sums? When we had the summation of 1 over n minus 1?
Wait, Mister, you don't have a worksheet, right?
No, I'm sorry, I don't know why I didn't have one, but now we do for next year. Okay, so how would we integrate something like that?
Decompose.
Yeah, right, we're going to have to decompose the fractions. Trying to get that marker out of there. There. This is the example that's in the book, but I don't want to do it the way they do it in the book. It's too hard. And then the next problem we're going to do is write off a 2008 multiple choice exam. Okay, so that's what you have to do. You're going to have to be able to do it. You could, I wouldn't want to do it, differentiate all problems, all the answers A through E. But that didn't look like fun. So we're going to decompose this fraction here, and that's the one that's in the book. And what I want to do is find out what fractions I added. Now they have some other partial fractions, but we don't have to worry about that because that's beyond the scope of this course. Okay, Matt?
Yes.
So first I'm going to factor this. How does that factor? Matt, what are the factors for that?
2x. Plus 1 minus -1 on the right side, plus 1 on the left.
Okay, how do you know if it's right? Multiply it out.
You don't know how to factor? Dude, what are we in third grade?
Well, that's how you do it. Okay, so we had two fractions that added up. We have a over 2x minus 1 plus b over x plus 1. We had different denominators, and we got this new fraction right here. So that's equal to 5x minus 4 over 2x minus 1. We'll leave it in factored form. It doesn't really matter. Okay? Mm-hmm. Did I factor it correctly? This is going to give me a positive 2x. That's going to give me minus 1, so I get a positive x. Should be right. I did practice before class. Okay, is that okay? Matt, you should probably be doing this with us.
We don't have a sheet.
Matt,
Well, get a piece of paper.
out and do it.
Okay. So what are we going to do? I don't want to deal with fractions, so let's clear the fractions out, right? So let's multiply by 2x minus 1 times x plus 1 for each term. And then things are going to cancel. The 2x minus 1 is going to cancel from this one. X plus 1s will cancel with this one. And they'll all cancel with the other side. So I'm going to be left with a times x plus 1. Now we don't have to worry about the fact that it's a sequence, because this x can be anything. Well, there's a couple of values it can't be, but for the most part it can be anything. Equals 5x minus 4. What can't x be? If you just were to look at that fraction, x can't be what? 0. 0? 0's okay. Negative 1 would make this 0, and 1/2 would make that one 0. Well, those are the values we're actually going to use to do this. Because x could be any number. So let's put in x equal to, which first one you want to try? Now what they do in the book is they try, I'm not sure, I think they distribute in group terms. That's too hard. X equals negative 1. And so we can figure that out. What's that going to give us? It's going to give us a times 0, so that's gone away, and it's b, and so it's negative 2 minus 1 equals 5 times negative 1 minus 4.
Negative 1/3.
So negative 3b equals negative 9. So b is equal to 3. If you can, go ahead. You should read the book. Go and see what they do and say, why would you do that? This is much easier. Of course, we really x can't be those values, but because it does make that 0. But I'm looking at an alternate equation and looking at that to use that to solve and find the values for a and b. Okay, I'm going to move this and put it on the next page. And those are the 4 problems. So even the assignment sheet is wrong. I looked at that and it didn't make sense to do those problems. These made much more sense. So all you have to do on 19A and 20A is do what we did to begin with. It's all it's asking for on the first 2 homework problems is just to do this piece. You don't have to do the problem. You don't find A or B. You just break it up. That's all. Yeah, well, I'll get to that side, but it's 19A and 20A, and then there's just 2 partial fraction problems. Plus, you should do the multiple choice one, this one right here. Okay, you ready? Well, I'm going to come back to this page anyway, but 19A, 20A, I think it's 21 and 23. And then they get hard. We don't need to do that. If you're interested, you could. Okay, what's the other x value I'd like to use? As I said, it's different. But I do want to double check those numbers. I know the first 2 are right, but I also check next 21, 23. So, Kevin, what's another x value you would like to put in next? We got to find out what a is. X equals 1/2. Oh, so you get a times what? I put a half in here. So 3/2. That's gone. B is, the coefficient of b is gone. Equals 5 times 1/2 minus 4. So I didn't get common denominators. I multiplied through by 2. Because I didn't want to deal with fractions. And so I get 3a, is however you want, is equal to 5 minus 8. So 3a, we're only partway done, is negative 3. So a is equal to what? Negative 1. That to me is the easy part. The hard part is going to be integrating it now. So let's see what we have. We have a over 2x minus 1, and a was negative 1. So I have negative 1 over 2x minus 1 dx. I'm going to integrate that part, plus I'm going to integrate, the other one was 3, and it was 3 over x plus 1. The second one is easier to integrate. Now, I can do this without a u substitution, but I'm not sure that you guys can. Yeah. Let's do the easy one. This is plus 3, and I'm integrating this, 1 over x plus 1 dx. So what's the antiderivative of that one? No? It's the natural log of absolute value of x plus 1 plus c. Now, when I look at this one, I can do u substitution, or I can kind of muddle my way through it and fix it so that it works. Matt, what'd you get for this one? Well, first off, I can pull out the negative 1. What am I going to do here?
Factor out the 2, 1/2.
I don't want to factor out the 2.
Well, then you can do...
I could do a u substitution, or I could just say, hey, that looks like 1 over x, doesn't it?
Yeah.
So this is minus 1 times the log of 2x minus 1. And if I check it, I'm going to be off by a factor of 2. Just 2. What's the derivative of this? It's 1 over 2x minus 1 times 2. I don't want the 2 there, so what do I have to do? Divide by 2. You could have done a u substitution to get the divided by 2.
Let's just do like a u substitution.
Well, I have a plus c for the whole thing. We'll just put all the constants together because they're arbitrary and I really don't care what they are.
I like the word arbitrary.
Doesn't matter. It's just a constant. I don't care what it is. I can leave it that way, or I could simplify it using properties of logs. And this is the way they left it, and so I'm pretty sure you're okay. If you want to make it a single log, because on the exam, let's look at the next one. Nope, they're not single logs there, so I'm probably not going to have you do that. It's up to you if you want me to do it. Okay?
So is that just the answer?
That's the answer. If you had taken this, let's say you didn't know what to do with this one, experience makes all the difference, Matt. I could have done a u substitution, and u is equal to 2x minus 1, then du is equal to 2dx. So you can see I get a 1/2 of 1 over u du. If you prefer to see that. After you've done enough antiderivatives, you won't need to do that. There's big discussion on the listserv. Some teachers don't even believe they should give you a u substitution. You should just look into it and see what the outer function is, what the inner function is, and I don't think it's that easy. It's a tool. I don't use it. Well, they don't let their kids use them, and I disagree. But that's my opinion. Okay. Why don't you guys try that one? Check the homework assignment. I feel like it's just not right. It's the 2008 multiple choice exam. Is probably 19. I'm pretty sure you'll have one of these. It'll be pretty comparable. Marcus, you going to go up and do it on the board?
Wait,
Do you really think that's going to happen?
No.
I beg to differ.
Yeah.
Yeah, 20. That's right. That's a fine assignment. The 21 and 23 was that I just changed the other ones. Same thing we did before. Should we do it together?
Yeah.
Okay.
Oh.
So, this is what I want to decompose.
It's really funny. Missy, do we get time to do this or not?
Yeah, they said they were stuck. So it's going to be a over 2x minus 3. And Mitch, guess what? You don't have to factor this one. It's factored. Right.
Miss Joe tried.
Okay.
You do that?
Yeah, who does?
I used to. As a plus.
Yeah, that's
Okay.
I don't like the color.
Oh, you don't? You don't have to use it. Plus 4 or something before.
You said it's still be that same. I've seen
So then you're gonna want to do X.
Pretty sure I saw that one.
B equals 2.
I don't know.
No.
4, negative 4, negative 7,
Isn't it?
negative 14, so.
Well, it kind of
Yeah.
shows me how you got that. Because,
Negative 2,
yeah, that's,
negative 4 minus 7 is negative 7. And then negative 14.
yeah.
Yeah, but we're going to do the whole problem so we know how to do it.
And then
So 3 is
3,
Oh.
3 half.
why? But
Ew.
you don't say. Well, that has that's negative.
Long distraction.
Negative 7 equals 7, right?
Actually,
Yeah, they're not animals.
yeah, they are equal.
Oh, they can't see that.
Alright,
So actually-
so 3.5 equals
Write it down. Write it down.
equals 10.5. 3.5 equals 10.5.
How do you get b equal to 2?
Because you do negative 2 in there, negative 4 minus 7 minus 3 is negative 7.
That's right.
7 times negative 2 is 14. So
Well, I forget
negative
what that
14.
is. But- Okay. Show the work.
But I don't want to show work.
Oh, but you have to show work. Remember, on the exam, you're getting points for your intentions. If you don't make your intentions clear, and you make a mistake, it's just plain wrong. Nat, put your phone away.
Look at the coolest thing I've ever had.
Which one is it?
Matt, after May 9th, you can do that all you like.
I'm going to do a project on blobfish.
On what?
Blobfish. Just Google it.
I can't even spell it.
Basically, what's
BFIS.
10.5 divided by 3?
Two fractions. It's 10.5. It's 11 halves divided by...
Fish. R space M-O-N.
3.
Space
It's wrong.
I.
Oh, Kevin.
That equals 3.
That's 3.
No, you're right.
Yes.
Alright. Now what you do is you put it in there and integrate them.
Yeah, we're going to do it.
Show us how to do it.
Marcus, help him.
You put it in there, and it's going to be...
So,
Shoot. It is E over 2 by 3.
I've done that before.
Is A like a good number? Or is it gross?
It's 3.
And but look also at your multiple choice solutions. There's nothing ugly there either.
Did you Google blobfish?
I doubt it.
It'll change your life.
Did you guys look
No.
They have
You don't even know what's
It's like,
they're like, oh, my.
has little things.
They're like,
It's got a big thing.
And I said I'm pretty sure
It
I'll...
says a author of those.
That's wrong.
Out blobfish.
I don't know, is it right?
I agree.
X minus 3.
Well, this will be 3 halves.
Hold on.
Yeah.
Okay, look at the answers.
Yes.
This one on B, they forgot the half. Everything else looks good. C, they have a sign error. Usually, now, one is usually positive, one's usually negative. But this is the one with the 3 halves. What?
See, it's minus 2.
Yeah, right there.
Okay. Yeah.
But then they have the 3 halves. And D is, D and E are like, we have no idea what to do. They're just grasping.
Because it looks smart.
Right.
That's normally what I do. I go with the one that looks smart.
Not always is it true, and these all have logs, more than half have logs in it, which might pull me that direction. But that's not always true, so you gotta be careful. Okay,
Lots.
let's look at questions on 5.6, integration by parts. Okay. Hey guys, 9.
I didn't get 9.
I think I haven't looked at it, and my guess is we probably have to do this twice. Oh, I bet you guys didn't simplify this before you began. That's why you didn't get it.
I even looked at your answers and
Well, you didn't leave it in this form, did you? We need to simplify this. This is x to the 1/3, which is 1/3 times the integral of the log of x. You always simplify your logs. Now I have that one memorized because we just did it yesterday. Should we do it again?
What is it?
It's x log x minus x. Because I do it so often. So when you choose your u's and your dv's, because it's uv minus the integral of v du, So I would like u to be something that will change form or go away. And if I make dv equal to the log, I'm in real trouble because that's what I'm trying to figure out. So can't do that. So make this the natural log of x. Then what's du? 1 over x times dx. Then dv is equal to, girls, dx. You have stuff to work on. And v is equal to, no, you have a new assignment now. Remember? Partial fractions? Okay. So it's 1/3. And it's u times v. So it's x log x. Remember, it's just reversing the product rule.
Wait, how can you bring up
Because it's 1/3 of this antiderivative. This is an exponent. Do you remember the log of x to the r?
ln of x to 1?
R times the log of x. You always want to simplify logs with exponents and such. Okay, then it's the integral of v, which is x times du. And what's going to happen to the x's? They're going to cancel out. So I get 1/3 x log x minus the integral of dx, which is 1/3 x log x minus x plus c. C could be in the parentheses or out. Doesn't matter.
Pretty sure there wasn't an ln of x.
Oh yeah. Antiderivative log is x log x. Other ones? You can work. I'm just answering questions. I don't think you need to be able to do it, but 13 is hard. Sure. Yeah, we skipped 13, although it's a nice little one. The inverse tangent of 4t. That's going to need a couple substitutions. Unless you can just, if you're intuitive and you know what to do with that 4. Okay, we ready to change slides? Not yet? I'll save it. I'm saving these all now as PDFs, so you don't have to have Smartboard software. You can just go in and open them up.
We still doing YouTube videos too?
Yep.
Was what?
Yesterday's is up there. Okay, it's the integral of the arctangent of 4t dt. I could, but not many people are looking at them. All I have to do is put ads in there.
How do I get
Oh, you just go through Schoology and go through click videos. Otherwise, you can find all my videos if you just search Golden Bus. Okay, I don't like that notation. I like this notation. It's a good question. I don't know. Okay, I don't want to make u equal to the inverse tangent because that's what I'm trying to find. I don't know how to do that. So how about if we make this u, plus I want it to change forms, and let's make this dv. So it's u times v minus v du. So if u is equal to the inverse tangent of 4t, what's its derivative? Remember the derivative of the inverse tangent? 1 over 1 plus x, whatever x is. It's 4t squared times 4. And then dv is going to equal dt. So v is just equal to what? T. I guess I'm going to need a couple substitutions. Okay, maybe it's just one more. So it's u times v. So it's t times, so we're just undoing the product of t times the inverse tangent of 4t. minus the integral of v du, which is 1 plus 16 t squared. Hope I did that right. Oh, and I do have a 4 there, so we'll put the 4 in front. And you're going to probably need a u substitution to do this one. I think I'm going to get my constant wrong if I don't, honestly. What would you like u to be?
Don't you do t plus 16 t minus 15?
That would be harder. Because you can't break this to t over 1 and t over that. That's why I'm telling you, if you're having problems with this, then you haven't done 5-5 and you need to do 5-5. It's u substitutions. I'm going to let u equal 1 plus 16t squared. Because I see the derivative of t squared. Forget the constant, that's unimportant. But the derivative of t squared is t. You know, unless it's in a parentheses, then it's a different matter. This is what, 32t dt. So I'm going to solve for t dt. So what's going to go out in front of this? 1 over 32. And it's bookkeeping. I think that's the problem for a lot of students in calculus, is that you don't want to keep track of everything, but you have to. And then this is 32, the integral of, and let's see, t dt is du, and this is u. And my AB students want to integrate 1 over u squared and say it's the log of u squared. No, it has to be 1 over u, 1 over x, 1 over z. No squares, nothing like that. Okay, so now we can do this. This isn't too bad at all. So it's t, question? Ask. And this reduces to 1/8, and then this is the log of the absolute value of u. I'm going to put absolute value in just because I want it to be a habit. I don't need it. Why don't I really need the absolute value? Because this part right in here is always greater than 0. So I'm safe. And that's the answer. It's just undoing the product rule. Pardon? Question? Oh, okay. Other ones you want to look at? Or just time to work? Sorry. Just be careful of the definite integrals, because when you do the u substitutions, just go back to, I always, it works for me to go back to the x's and then put the x's back in. Otherwise I get confused, because now you got so many u's and substitutions going on that it's, when you have the u and the v, and yeah, and then you have x's. Okay. Should be there. I thought I put it up. No, video. So I'll look.